Okay, today we're going to be doing a review on the effects of transformations. So how does that affect our shape and our points when we do the different transformations that we've learned about? So we're going to take a look at a few problems. These will be similar to problems that are on your mastery test, so feel free to refer back to them as you are preparing for your mastery test. All right, so let's take a look at this first one. We have quadrilateral ABCD, and it says it's gonna undergo a reflection, which is also a flip across the x-axis to form quadrilateral A prime, B prime, C prime, D prime. And again, that prime or that little one mark there is just to let us know that is the image after we have done the transformation. They want us to know, where does coordinate A prime end up? So we really just have to look at this point A, and notice point A is located right here at -5, -3. We need a little parenthesis there. So that's our coordinate point for A. We are going to reflect this, a flip across the x-axis. And so basically it just ends up the exact same distance, but on the other side. It's like a reflection. So right now, point A is 3 down from the x-axis. When we reflect it, it's going to end up here, 3 up above the x-axis. And that we can label as our A prime. And that point is then at -5, 3. Then the reflected quadrilateral, so then we're going to take our A prime and it's going to be translated. That's that word for slide. We're going to slide the quadrilateral 3 units right and 2 units up. 3 right, 1, 2, 3, and then up 2. There we go. And again, that's going to be labeled my A double prime. And that point is located at -2, 5. So that's some practice with reflections and translations. All right, next one. We reflect a triangle PQR. Here are the coordinates across now the x-axis, across the y-axis, and across the x-axis again to form a triangle. So it goes through quite a few things to get to our P prime, Q prime, and R prime. I'm going to use some graphing paper here. Sometimes you're just going to have to graph it out, follow the directions. So that would be our x-axis, our y-axis. And let's go ahead and plot that triangle. So P is at -4, -4. So 4 left and 4 down. That's going to be our P. Q is at -1, -3. Q, and R is at -3, -1. And we can make see how straight I can draw with this here. All right, so there's our triangle. And we're just gonna really wanna know where P prime ends up. So I'm just gonna start by taking this point and following the direction. So it says it goes reflected across the x-axis. Well, right now it's down 4 here at -4. So when it's reflected, it's going to end up opposite side, but of the x-axis. So it's going to end up 1, 2, 3, 4 up here. Then we go across the y-axis. So same thing, it's going to just reflect exact opposite over here. So there's 4, a distance of 4. So it's going to be same distance, just on the opposite side, because now we're reflecting across the y-axis. And then it reflects back again across the x-axis. So it just kind of goes around here. Again, it's 4 above. So when I reflect it again, it's going to end up 1, 2, 3, 4 below. And that finally gets us to just our P prime. That took a lot of steps there to get to that point. And now that ends up, I would be at 4 positive on the x-axis. So my x value of my ordered pair is 4. And I'm still down here at -4 for the y value. Okay, this one, we're going to get into rotations now. It says you rotate, and again, that's just another word for that we're turning. Triangle ABC with these vertices, and this is important. We're going 90 degrees. So remember, 90 degrees kind of makes that perfect L shape. And so you can kind of think of that turning, and with our coordinate plane, we have that as well. Like if this were our X and our Y, if I turn it 90 degrees or rotate it 90 degrees, you can think like if I were to turn it counterclockwise, going that way, so to the left, it'd be like my X axis ends up standing straight up, Y goes to the left. So whatever point is here is kind of going to get rotated and end up, you know, over on the other side. And we're going to go around the origin to form our triangle A prime, B prime, C prime. We want to match the new vertices of our coordinates. So you can graph this out. And I also find it helpful to Google and look up the rule for this. So if I Google 90-degree counterclockwise rotation rule, you will find it tells you that if I have a point XY, after I do that rotation, it's going to end up -YX. So that means the X and Y values kind of flip-flop, and the Y value will become a negative, or the opposite. So going back, my original A is -3, 1. And so my A prime is going to end up, the X and Y flip-flop. So 1, -3. The Y value will also be a -1. And so here's that point. I could just drag and drop it into that spot there. Our B value, the vertex, was at -2, 2. And so when I follow that rule, the X and Y will flip-flop. However, the Y also becomes the opposite. So my new value, or B prime, is going to end up at -2, -2. And then the last one, -3, 4. So same thing. The X and Y are going to flip-flop, and that's going to become the opposite. All right, so hopefully that helps. Okay, so, all right, so our next one says quadrilateral ABCD is transformed to create A prime, B prime, C prime, D prime. We're going to match the coordinates of A prime with the transformation that created it. let's see. So we really only need to look at point A. And if we start off with our point A, we are at 2, -4. And quadrilateral ABC is reflected over the x-axis, well, that means it's going to flip over the x-axis. Right now it is down 4. So when we do a flip, that point A is going to end up here. And that would be our A prime in that case. And that would be located at 2, 4. So that would be after reflected over the x-axis. How about this one? If a quadrilateral ABCD is translated 2 units right and 1 down. So again, back up to our point A, if I go 2 to the right and then 1 down, now I'm going to end up at 4, -5. My x-axis, or my x value ends up at 4. My y is now at -5. Scale factor of 3. Scale factor means we're going to be either increasing the size or decreasing. It depends if you're multiplying by a whole number or a fraction. In this case, it's a whole number. It's going to get bigger by 3 times the size. So we have to multiply our x and y value both by 3. So looking back at that point A, if I multiply the x value 2 by 3, that's going to make a new value of 6. And then -4 times 3 would be -12. So once it's dilated by a scale factor of 3, that new point is going to end up at 6, -12. And then the last one, the rotation 180 degrees clockwise, so to the right, half a circle, basically, to the right about the origin. I always like to use a rule for these. I think the rotations are hardest to do on the coordinate plane unless you have like some tracing paper to go over. So again, I looked up that rule on Google, and it tells me when I do 180 degree clockwise rotation, my point xy is going to become -x, -y. So basically the x and the y both change to the opposite signs. So my original was 2, -4. After 180 degree clockwise rotation, it's going to end up -2 and +4. They both just change to the opposite. All right, let's take a look. I may need to zoom this one. Zoom out just a little bit so we can see. Everything in one picture here. So it says vertex A in the quadrilateral lies at -3, 2. If you rotate it 180 degrees clockwise around the origin, what will be the coordinates of A prime? All right, so again, since it's a rotation, I'm not going to do the graph. I really like using the rule, and I know that xy is going to become -x, -y. And so it told you that A was at -3, 2. So after we do that clockwise 180 degrees, both the x and the y are just going to change to the opposites. That would make that 3, -2. And that is one of our choices. So that worked out. All right, this one says triangle XYZ with vertices X at -2, 0, Y -2, -1, and Z -5, -2 undergo a transformation to form triangle X prime, Y prime, Z prime. And that ends up with the vertices at these locations. The type of transformation that it underwent was what? Wow, that's kind of difficult to just see without actually taking a look at the graph here. So let's go ahead and graph. What do those triangles end up looking like? So I'm going to do our first one, XYZ. X is at -2, 0. Y was at -2, -1. And Z is at -5, -2. So that's our first triangle. Oh boy. It's supposed to be straight and look like a triangle, but all right. And then our next one says the prime ends up at these locations. So for X prime, we are over here at 4, -2. That would be our X prime. Y is at 4, -3. And Z 1, -4. And I feel like something is off. Did I go down far enough? Oh, let's see. Let me try that one again. All right, so let's try the prime again here. So we end up at 4, -2. And that would be our X prime. Y prime is 4, -3. And Z prime ends up at 1, -4. There we go. And again, could connect them. So these triangles, if I would have drawn this one a little bit better, are congruent. They're exactly the same. They're not turned in a different direction. The X is on the top as the top vertex here, and it stayed on top. So the orientation stayed the same. I can tell that this is a slide, that it was a translation. I just need to count how many did I move it. So if we just look at one point, X, how many did I go over and then down? Well, it looks like I went 6 to the right and 2 down. And again, that would be a translation. All right, and then it says this triangle, we now take it and undergo another transformation to form the double prime. These vertices end up at 4, 2. So 4, 2 would be our X double prime. 4, 3 is our Y double prime. And Z double prime ends up there. And now do my best to make this somewhat straight. Now I can see this is kind of turned around a little bit more. And the X and the Y are still on the side, but now they're flip-flopped. And if I were to fold this on the X-axis, these are going to match up exactly. They're an exact reflection. So it was a reflection across this X-axis. If I can fold it on this X-axis and they match up, it would be a reflection on the X-axis or across the X-axis. All right, we have a triangle shaped garden, and he drew a model on a coordinate grid. Here were the original vertices. He wants another similar shaped garden, but he's going to create this one by dilating. So again, there's that either bigger or smaller by a scale factor of 0.5. I can see since it's a 0.5, it's going to get smaller. What are the coordinates of our new one? So basically I'm multiplying everything by a half, 0.5. And so this point, if I multiply both those numbers by half, are going to become 2, 1. Multiply this one by half, 1, 2. And this in half, 3, 2. And those are my A prime, B prime, and C prime now. And so that would match up with that one. It's a lot of letters to look at, so you just got to be careful when you're looking through those. All right, this one says you reflect triangle PQR with vertices, and then we go across the y-axis to get our P prime, Q prime, R prime. What are the new coordinates of the triangle? Well, we can take a look at that. Maybe if we just graph it out. I'm going to give myself enough room here since we're in the negatives. So let's say there's our X and Y axis. Our original points were at -2, -4. Q is at -3, -1. And R is at -4, -4. And there's our original triangle. So it goes across the y-axis and we end up with our new one. And a reflection across the y-axis means each point will just be on the opposite side of that y-axis. So this is 3 to the left of the y. If I reflect it, it's going to end up 3 to the right. And that would be my Q prime. P is 2 away. And so when I reflect it, it's going to end up 2 to the right. That would be P prime. R is 1, 2, 3, 4 to the left of the y. So when it's reflected, it's going to become 4 to the right. And that would be our R prime. So that is our new triangle after the reflection. I just need to pick which points match up. Well, Q ended up here at 3, -1. P prime here ended up at 2, -4. And R prime is here at 4, -4. Got a couple more just to go over with you. This one's that scale factor of 2. Again, whenever you're dealing with scale factor, you're multiplying, whether it's a whole number or the decimal. So we're going to multiply everything by 2. So here's our original 2, 3. So once it's dilated with a scale factor of 2, it's going to become 4, 6. I just multiply both of those by 2. Same thing here. Multiply both of those by 2. And same thing here. And that would be your new point, A prime, B prime, and C prime. All right, here we go. The marching band stands in triangle formation. The drum major is at point A. There's our point A, which is one of the vertices of the triangle. They start to march 3 units left and then 5 up. Let's see where that takes us. So 3 left and 5 up. So we're going to end up here. Then they continue on, marching 2 left and 2 up. So let's follow those directions. 2 left and 2 up. After the movement, where will the drum major be standing? So ended up here at 1, and that would be up at 3, 1, 3. All right, hopefully that will help you prepare for your mastery test on the effects of transformations. We'll see you on the next video.